Good morning students, this is Lalpur Khalsa College of Engineering Jalandhar and today we discuss the F test or variance ratio test for CSE class. So as from the name of the test it is clear that this test is related to the variance. So in the testing the significance of a difference of a two means of a two samples, we assume that the samples come from the same population or population with the equal variances. So to apply the t-test, we always assume that the samples come from the same population or population variances are equal. So the objective of F test is to discover whether the two independent estimates of population variances differ significantly or whether the two samples may be regarded as drawn from the normal population having a same variance. So basically the F test is related with the variance equality. So in F test we check that the population, normal population having the same variance or not, or independent estimate of the population variance different significantly. So F test is basically related with the variance of a population or variance of a sample. So hence before applying the t-test for significance of a two means, we have to test the equality of population variance by using a F test. So if in the question this is not given that population variances are equal, so before to apply the t-test we have to apply the F test to check the equality of population variances. Now there are some assumptions of F test. First assumption is that the parent population from which the sample is drawn is normally distributed. That means the population from which we take the samples is normally distributed. Sample observation are independent and random. That means the sample points or sample observations are independent and random. Population variances are unknown. That is our third assumption that population variances are unknown. So if these three conditions are satisfied, then we will able to apply the F test. So F test, firstly we discussed that F test is used to check the equality of the variances. So if in a t-test, to apply the t-test, it is not given that population variances are equal, so firstly we apply the F test, and these three are the assumptions of F test. First assumption, the parent population from which the samples are taken is normally distributed. Second, sample observation are independent and random. Third, population variances are unknown. Now we discuss the procedure how we can apply the F test. So let xi, I running from 1 to n1, that means x1, x2, x3, xn1, and yj, j running from 1 to n2, that means y1, y2, y3, yn2 be two independent samples of size n1 and n2. So the size of first sample is n1 and size of second sample is n2 with the two independent samples. So let s1 square and s2 square are the two normal are the variances of these two samples. That means s1 square is a variance of first sample, s2 square is a variance of second sample, and population variances are sigma 1 square and sigma 2 square. So to apply this test, first we suppose we have two samples. In a first sample there are n1 observation, and in second sample there are n2 observation, and s1 square and s2 square are the variances of a sample, and sigma 1 square and sigma 2 square are the variances of a population. So we set up the null hypothesis that sigma 1 square equals to sigma 2 square equals to sigma square. It means population variances are similar, or in the other words we can say that H naught is that the two independent estimates of common population variances do not differ significantly. Okay, there is no difference between the population variances. So after setting up the null hypothesis, we can set up the alternative hypothesis as H1 is sigma 1 is not equals to sigma 2 square, or sigma 1 square is greater than sigma 2 square, or sigma 1 square is less than sigma 2 square according to our requirement. So after setting up of the null hypothesis, then we calculate the test statics. In this test statics is given by S1 square over S2 square, and this follows a F distribution with n1 minus 1 comma n2 minus 1 degree of freedom. So first formula is applicable if S1 square is greater than S2 square. If S1 square is less than S2 square, or that means S2 square is greater than S1 square, then we apply the second formula. And our second formula is S2 square over S1 square. So if S1 square is greater than S2 square, then we apply the first formula. If S2 square is greater than S1 square, then we apply the second formula. For second formula, degree of freedom is n2 minus 1 comma n1 minus 1. So the value of S1 square and S2 square are found with the help of this formula. S1 square equals to summation I running from 1 to n1 xi minus x bar whole square over n1 minus 1. S2 square equals to summation j running from 1 to n2 yj minus y bar whole square over n2 minus 1. And we know that x bar and y bar are the mean of the first sample and second sample respectively. So this formula is used to find the value of S1 square and S2 square. So since f is based upon the ratio of two variances, it is known as variance ratio test. So here we check that F test use the variance of first sample, variance of second sample. So this test is also known as variance ratio test. Now we discuss the one important remark. In numerical problems, usually the sample variance S square is given, from which we calculate the value of capital S square. In the number of the numericals, the sample variances are given. From these sample variances, we have to find the value of capital S square. And we can obtain the value of capital S square by using this relation. N into small s square equals to n minus 1 into capital S square. So capital S square equals to n over n minus 1 square into small s square, where this small s square is the variance of sample. So from the variance of sample, we find the value of capital S. Then after finding the F statics, then then we find the table value. So after finding the table value, if we check the table, this is the table for F distribution. So here 1, 2, 3 in this form represent the degree for the numerator, and here is the degree of denominator. From this side we check the degree of numerator, and from this side we check the degree of denominator. Let us suppose we have the 9 degree for numerator and 12 degree for denominator. Then from this side 9 and 12 from this side. Our answer is 2.80. So this represents the degree for the numerator on row side, and column side represent the degree for the denominator. This table is used to find the table value of F distribution. So after finding the table value and the calculated value, then our last step is comparison. Or after comparison we get a one conclusion. If calculated value of F exceed the table value, then we conclude that the sample could have come from the two population with the same variance. So the steps to apply the F test, first step is same. We set up the null hypothesis, alternative hypothesis, then we calculate F statics. So F statics is given by S1 square over S2 square, and this follows a F distribution with N1 minus 1 comma N2 minus 1 degree of freedom, and this is used if S1 square is greater than S2 square. Otherwise we can use S2 square over S1 square, where the value of S1 and S2 square is given by using this formula. So next we discuss if the sample variance is given. From this sample variance we find the value of capital S. Capital S square is given by n into small s square over n minus 1. So now we discuss the numerical problem for the F test. In two independent samples of a size 8 and 10, the sum of square of deviation of the sample values from respective sample means were 84.4 and 102.6. Test whether the difference of variance of the population is significant or not. So in this problem two samples are given. The size of first sample is 8, the size of second sample is 10. So let us suppose first sample, the size of first sample is denoted by N1. N1 equals to 8 and N2 equals to 10. So after writing the value of N1 and N2, next we check sum of square of deviation of sample value from their respective means. That means the difference of the respective value from mean, after finding the difference, then square, then summation is given 84.4 for first sample and 102.6 for the second sample. So x minus x bar whole square summation is 84.4, summation y minus y bar whole square is 102.6. So after writing the given, now we set up the null hypothesis. We set up the null hypothesis that sigma 1 square equals to sigma 2 square. That means there is no significant difference between the population variances. That means we set up the null hypothesis that the population variances are equal. So after setting up of the null hypothesis, then we set up the alternative hypothesis H1. Sigma 1 square is not equals to sigma 2 square. So first we calculate the value of S1 square, as we know that S1 square is summation x minus x bar whole square over N1 minus 1. So this value is 84.4. 8 minus 1 is a 7. If we divide 84.4 with the 7, this become a 12.057. So after finding S1 square, next we find S2 square, summation y minus y bar square over N2 minus 1. This is equals to 102.6 divided by 10 minus 1, 9. If we divide these two, This is equals to 11.4. Now since S1 square is greater than S2 square, so F is given by S1 square over S2 square. If we divide these two, the answer is 1.0576. Now we find the degree of freedom. Since S1 square is greater than S2 square, so the degree of freedom is 7, 9, and 1 minus 1 and 2 minus 1. Now corresponding to this, we find the table value. So the degree of freedom is 7, 9. 7 from the numerator side and 9 from the denominator side. This is equal. Degree from the numerator side is 7 and denominator side is 9. So this is equals to 3.29. So we find the value 3.29 is a table value and calculated value is 1.0576. Now since the calculated value is less than the table value, so we accept our null hypothesis. If we accept our null hypothesis, that means there is no significant difference between the variance of population. So to apply the F test, first we set up the null hypothesis, then we find S1 square, S2 square, then we find F statics, then our last step is conclusion. Thank you.